Section 4.1 in your textbook is titled Factors and Prime Factorization. We're going to start off with a couple definitions here. First is a prime number. So we want to differentiate between a prime number and a composite number. A prime number is a whole number, so no fractions, no decimals, with exactly two factors, one and itself. A whole number with exactly two factors, one and itself, and those are the only two factors. A composite number is also a whole number, but it's a whole number that has more than two factors. Hopefully these are terms you are familiar with. Let's work through some numbers here. So an example of a prime number would be 7. The only thing that multiplies to 7, the only factors, the only whole numbers that multiply to 7 are 7 times 1. 7 times 1 is 7. And there's no other factors of whole numbers that multiply to 7. Remember, whole numbers have to be positive or 0. So yes, -1 times -7. When we're talking about factors, we're just talking about whole numbers that multiply to 7. Another example would be 2. 2 times 1. 1 and itself. 3. 3 is prime. 3 times 1. Only thing that multiplies to 3. 4. Well, 2 times 2 is 4. So if I'm listing out the factors of 4, well, 1 times 4 and 2 times 2. So there are more than two factors, so 4 is a composite number. 5 is prime. 6, 2 times 3 is composite. And so on. Notice the only even number that is going to be prime is going to be 2, because every other even number can be divided by 2, has a factor of 2. 9, 3 times 3. And so on. I want you to think for a moment about the number 1. Is the number 1 prime or is it composite? Does it fit this definition? A whole number with exactly two factors. Well, 1, the only whole numbers that multiply to 1 are 1 times 1. So it has one factor. It does not have exactly two factors. It's not prime. And because it only has one factor, it does not have more than two factors. The number 1 is neither prime nor composite. It's not a prime number. It's not a composite number. When you're taking a look at a number and trying to figure out if it's prime or composite, obviously the smaller numbers we're super familiar with. 10, 2 times 5. 11, we know there's nothing that multiplies to 11 except 11 times 1. If you're looking at the bigger numbers, there's some rules on how we can tell if a number is divisible by something or not. To tell if it's divisible, if it's divisible by 2, that one should be pretty easy to tell if it's divisible by 2. It's divisible by 2 if it's even. If it's an even number, if it ends in a 2, 4, 6, 8, or 0, then it's divisible by 2. Odd numbers are not divisible by 2. The number 3, to tell if it's divisible by 3, add the digits. And if that number is divisible by 3, then the number itself is divisible by 3. So if we look at the number 108, we can very quickly tell that it's divisible by 3 by doing 1 plus 0 plus 8 is 9. 9 is divisible by 3, therefore 108 is also divisible by 9 works exactly the same way. Except we're now checking to see if it's divisible by 9. 1 plus 0 plus 8 is 9. 9 is divisible by 9. So 108 is divisible by 9. The other primary one is 5. Divisible by 5 if it ends in 5 or 0. And 10 if it ends in 0. Those are the big ones that you should know. Number 4, you can tell if something's divisible by 4. You would check if it's divisible by 2 twice. Divisible by 2 twice. So like 500. 500 is divisible by 2 because it's even. Well, let's go ahead and divide that by 2 and get 250. And 250 is divisible by 2. So it's divisible by 2 twice. Therefore, 500 is divisible by 4. And 6 is 2 times 3. So you would check to see if it's divisible by both 2 and 3. So like 500, it's even. So it's divisible by 2. But 5 plus 0 plus 0 is 5, not divisible by 3. Therefore, 500 is not divisible by 6. So notice we kind of have rules for almost all of them. 2, if it's even. 3, we add the digits and check to see if that's divisible by 3. 4, divisible by 2 twice, because 2 times 2 is 4. 5 ends in a 5 or 0. 6, divisible by both 2 and 3. 7, there's really not a good rule for 7. 8, you could do similar to 4, but 8 is 2 times 2 times 2. So you would check to see if it's divisible by 2 3 times. 9, we add the digits and check to see if that's divisible by 9. And 10, the number has to end in a 0. Factors. When we use that word factor, the word factor is a number, a whole number, it should say. Oh, sheesh. That multiplies to the given number. A whole number that multiplies to the given number. And the prime factorization, so factor, we're listing out the numbers that multiply to a given number, but we want the prime ones that multiply to the given number. So prime factorization is writing a number as the product of prime numbers. We're going to write a number as the product of prime numbers. So example 1 asks us to tell whether a number is prime or composite. If it's composite, write its prime factorization. So 56. 56, right away I can tell this is an even number, so I could divide by 2. Since it has a factor other than just 1 in itself, this is composite. If it's composite, we have more work to do. We need to write the prime factorization. So we do that by breaking it down. We want to think about something that multiplies to 56. We said 2, and you could figure out, you could divide by 2 to figure out what the other factor is. That would work fine. You might want to try to think of some other factors that multiply to 56. I'm going to go 7 times 8. 7 times 8. This is called making a factor tree. Every time I find a prime factor, 7 is prime, I'm going to circle it. 8 is not prime, it's composite, so we need to break it down further. 8 is 2 times 4. 2 is prime, so we're finished there. 4 is 2 times 2. 2 is prime, circle. 2 is prime, circle. To write the prime factorization, we have 2 times 2 times 2 times 7. 2 times 2 times 2 times 7. 2 times 2 times 2, we're not going to write it as 2 times 2 times 2. We have 2 times 2 times 2, that is, use exponents, 2 to the third power times 7, and I only have 1 7. 2 cubed times 7. 83. 83 is a tougher one. We know it's not divisible by 2. I can take that one off right away because it's an odd number. So I'm going to kind of list them up here. You don't have to, but so we know it's not divisible by 2. And if it's not divisible by 2, it's not divisible by any other even number. I can get rid of all these other even ones. Let's check 3. 8 plus 3. I add up the digits. I get 11. 11 is not divisible by 3. 11 is also not divisible by 9. 5, it does not end in a 5 or a 0. 7's the one maybe we should be concerned about. Let's think about, well, 7 times 10, that's 70. 7 times 11 is 77. So 7 times 12, that's going to be 7 more than that. That's 84. Notice we missed 83 there. It's not divisible by 7. You might want to think through 11. Well, 11 times 7 is 77. 8 times 11, that's going to be too big. Notice this is a prime number. The only thing that multiplies to 83, the only whole numbers that multiply to 83 are 1 times 83, therefore it is prime. Parts C and D. C and D. This one ends in a 0, so I know it's divisible by 10. This is composite. This one ends in a 2. It's even. This is also composite. Let's work through the prime factorization. Because it ends in 0, it's divisible by 10. 10 times 65 gives us 650. Neither of those are prime. I can't circle either one. 10 is 2 times 5. 2 is prime. 5 is prime. 65. 65 ends in a 5, so we know it's divisible by 5. 5 times what? So we're thinking through 5 times what gives us 65. We can do 65 divided by 5. Five times what is 6? Well, 1. 5 times 1 is 5. Subtract. 5 times 3 is 15. So 5 times 13. 5 is prime. 13 is prime. So we have 2 times 5 times 5. That's 5 squared times 13. We know 32 is composite. 32 we said was divisible by 2, so let's do that. 2 times 16. 8 is 4 times 4, or 2 times 8. Either way, you'll get the same answer. Whoops, shouldn't have circled those. 4 is 2 times 2. 2 is prime. This 2 is also prime, as are these two 2's over here. 2 times 2 times 2 times 2 times 2, 2 to the 5th. And then the last thing is a monomial. A monomial is a number. So it could be 5. A variable. Could be x. X is a monomial. Or the product means multiply, of a number and one or more variables raised to whole number powers. So it could just be a number, it could just be a variable, or it could be a combination of numbers and variables that are multiplied together. So like 10x to the 11th, y to the 5th is a monomial. 3 is a monomial. W squared is a monomial. 3 plus x, not a monomial. I've got this plus sign in between. I'm not taking the product. Product means multiply. It is not the sum or difference. If I have plus signs in there anywhere, it is not a monomial. And then the only example here asks us to factor 50a to the third b. 50a to the third b. The number part, we do the same. 5 times 10, 5's prime. 2 times 5, 2's prime, 5's prime. 2 times 5 squared. Nothing new there. The variable part, we just list it out. A to the third, we write as A times A times A, and B, I just write as B. That is it for section 4.1. If you're having problems or questions, please let me know, reach out.